In our previous section, we have seen the configuration related to the VPC, right? So, in our previous lecture, we have also discussed about the Cisco Fabric Services Protocol, right? So, the CFS do the comparison of the configuration between both of these peers, and if the configuration is not consistent in both of the peer devices, then based upon the type of consistency, it is going to take some decision. For example, if there is a type 1 consistency failure between the two devices, then all your VPC member ports are going to be impacted. For example, if I go to N7K1, so in our previous lecture, we have created a VPC2, right? So VPC2 is between N7K1, 2 and N5K1. So I have also created a VPC3, which is between N7K1, N7K2 and N5K2. So if I go to, let's say, for example, N7K2, if I do a show VPC, so we can see here we have two VPCs, VPC2 in port channel 2 and VPC3 in port channel 3. So VPC2 is going to N5K2 here, sorry, N5K1, and VPC3 is going to N5K2. So we were discussing about the consistencies, right? So if I do a show VPC, so we can see here there are some consistencies mentioned. For example, let me type it again. So there are two type of consistency. One is the first, let's discuss about the global consistency. If I do a show VPC uh, consistency check, consistency parameter, and then global. So you can see here there are couple of consistency mentioned. So on this side, you can see the name of the consistency. Maybe let's say the first one is the STP MST simulate PVST, or the BPD filter, or the edge guard, the STP disable mode, or the STP bridge assurance loop guard. There are a lot of consistency that are being mentioned here, and you can also see here it is mentioned the type. What's the type of consistency? Whether it is type 1 or type 2. Local value, it means that these values are configured on the local device, okay? Or for our device it's N7K1, okay? And on the right hand side it's the peer value. It means that these are the values that are configured on the VPC peer device. So if there is any type 1 consistency failure, it is going to impact all your VPCs. For example, if we check the show VPC role, so if you remember from our previous section that the N7K1 is the secondary device, and N7K2 is the VPC primary, right? So if we do a type 1 consistency failure, for example, let's say uh, right now the spanning tree mode is rapid PVST, right? If I do a show spanning tree summary, so the switch is in a rapid PVST mode or in the RSTP mode, right? And if I go back to switch 1 also, if I do a show spanning tree summary, you can see here the spanning tree mode is rapid PVST, right? And also, if we do a show VPC consistency parameter global, so the spanning tree mode is also a type 1 consistency. So let's see what happened if we change the spanning tree mode. So if I do a spanning tree mode, let's say I do MST here, okay? Now, if I check show VPC, so now as so what will be the effect of that? Because N7K1 is the secondary device, right? And N7K2 is the primary device. So because we do have a you can see here that port channel 2 or VPC2 and VPC3 both are now down, right? And what's the reason? The reason is the global compact consistency failure, because we do have one global consistency failure. That is why on the secondary VPC peer, the VPCs are down, or the all the member ports, VPC member ports are down. If you do a show VPC consistency parameter global, you can see here, if you check the one by one value, you can see here the STP mode on the local device it's MST, and on the peer device it is the rapid BSD. That is why, just because of the type 1 consistency on the secondary device, the all the VPC member ports will go into down state. Even if you check show port channel summary, here also you can see VPC2 is in port channel 2, so all the member ports are down for port channel 2, and VPC3 is in port channel 3. That is why all the member ports of VPC3 is down, but there will be no effect on the primary. Your traffic is not going to be impacted. The only thing is that now your half of the bandwidth is cut, right? Because only primary VPC member is up now. So if I go to the primary, right? So this is the primary and 7K2. So if we do a show VPC here, now you can see here the port channel status on the primary device is up, right? For both port channel 2 and port channel 3. Because on this side also you will see this message that yes, the consistency is failed, but on the primary device your ports are still up. If you do a show port channel summary, your ports are still up. Also you can do a ping also. Let's say if I do a ping, so the IP of the server 2 is 20.1.1.100. You can see the communication is still going on, right? But the only thing is that the half of the bandwidth is cut because we do have the type 1 consistency failure, right? Okay, so now let's go back to N7K1, and now let's change it. Uh, let's say spanning tree mode rapid PVST. Okay, now let's wait. If I do a show VPC, now our member ports will come up again. Now you can see all the member ports are up now, because now we do not have any consistency parameter failure, or now the type 1 consistency is being resolved, right? So if I do a show port channel summary, so the important thing is that only the VPC secondary member ports will be impacted by the type 1 consistency. In the earlier version, when VPC was developed, in that case, if there was a type 1 consistency failure, then both of the devices uh, was impacted in that case. But in the later iOS, it was fixed, and there is a graceful consistency check feature that is by default now. And after that, what's the benefit of that is that if there is a type 1 consistency failure, then only the secondary device is going to be impacted. Okay, but in earlier versions, both the devices were impacted at that time, but right now only the secondary device will be impacted. Let's see some more example of this. Let's say if I do a show VPC uh, consistency parameter global. Let's try one more example of this. Let's say if I disable the bridge assurance on one side, let's say if I do a no spanning tree bridge assurance, if I do a show VPC, because this is the secondary device, now you can see again the port channel 2 and 3 on the secondary device are down, because now again we do have the type 1 consistency failure, and because of that all the member ports are going to be impacted. So all your VPCs are going to be down, your member ports will be down, because we have the type 1 consistency. If you do a show VPC global parameter, show VPC consistency parameter global, so now you can see here that the bridge assurance on your local device, it is disabled, right? and on the peer device on the N7K2 or on the primary device it's still enabled. That is why we do have type 1 consistency failure. Okay, so in the first, let's enable it. Spanning tree bridge assurance. Show VPC. Now your port channels will come up. Now it's up because now the consistency is resolved. There are some more consistencies on the global side. If you see here, there are type 2 consistencies as well. So when we do have the type 2 consistencies, your port channels will not be down or your member ports will not be down. It will just give you some message that you do have the type 2 consistency and you needs to resolve it. Okay, just to avoid any forwarding plane issues. So but it is not going to take any crucial action like shutting down the member ports like it does in the type 1 consistency. For example, you can see here the admin VLAN status. It is a type 2 consistency. For example, if I do show IP interface brief, so we have VLAN 10 and 20 here, and let's check here, show IP interface brief. We also do have the type, I mean VLAN 10 and 20. So if I go to switch one and if I do a interface VLAN 10 and if I do a shutdown, if I again check show VPC consistency parameter and global, so now you can see here, uh, you can see here we interface VLAN admin up. On the local device only VLAN 20 is admin up, but on the peer device VLAN 10 and 20s are up. So if I do a show VPC, you can see here it is not going to impact anything, right? So all your port channels will be up. It will just generate the type 2 consistency. It's a kind of warning for you that there are some misconfiguration or uh, the configuration is not consistent on both of your devices. You can also see here if you do a show VPC, it is showing you that there is a type 2 consistency, right? And it is also showing you the reason for this inconsistency, that SVI type 2 configuration incompatible. So it is clearly mentioning that there is some SVI related inconsistency, so you need to get it rectified just to avoid any forwarding plane issues. Okay, so this is the behavior for the global consistency checks. So let me make it up. No shut. So if you do a show VPC now, it will be resolved. Now you can see here there are the type 2 consistency status is also success. Okay. Okay, now let's see some consistencies related to the port channel or which are a part of the VPC. So for example, if we do a show VPC consistency parameter interface, so port channel 2 on port channel level also where we configure the VPC. So you can see here if I do a show VPC consistency parameter interface port channel 2, it is saying that VPC will be suspended in case of mismatch. So if there is any mismatch on these parameters that are mentioned here, then your VPC will be suspended. For example, okay, so if I do a show VPC consistency parameter interface port channel 2, so there are port level inconsistencies also. So our main goal is that if we are forming a VPC, so on both of the peer devices under the port channel, we need to make sure that these parameters must match. Otherwise, your VPC is not going to work. For example, uh, let's say I will do a quick one example, and then we'll move to our next topic. So for example, if we have the MTU, okay, so I'll go to, let's say, interface port channel 2, and let's say I change the MTU from 1500 to 9216. Okay, if I do a show consistency parameter check now, You can see here on the local device, the MTU is 9216, and on the peer device, the value is 1500. So it is a type 1 consistency failure, right? It means that on your secondary device, your VPC is not going to work, right? So if you check a show VPC, you can see here the port channel 2 is down because of the compatibility check failed for the MTU. So the main idea behind the consistency is that on both of the peer devices, we need to make sure that our configuration is consistent. And the best way to configure the VPC for any port channel is that on one side, once you configure the port channel and VPC and you do all the configuration, so what you need to do is you just need to copy and paste the configuration just to make sure that you are not doing any mismatch of the configuration, right? So we need to make the configuration same. So I'll go to interface port channel 2 and I will do a MTU of 1500, right? So that was all about the consistency parameters. Okay, so it will come up. So in our next section, we will discuss about the VPC and spanning tree. So in the consistency, you need to make sure, if I just brief you quickly. So for the global consistency checks, if I do a show VPC consistency parameter global. So we need to make sure show VPC consistency parameters global. So in your global parameters, so you need to make sure that all your configuration is consistent on both of the side. For let's say you need to have the STP mode same on both side, right? Or maybe the bridge assurance is must be enabled on both side. The loop guard, for example, if you are enabling it on the global mode, then it must be enabled or disabled on both side. So that's these are the things that you need to make sure. And in the port channel consistency also, we need to make sure that uh, we are I mean our configuration is consistent on both side. And the effect of this consistency will be only upon the secondary device. Here the primary device is not going to be impacted by this consistency. The type 1 consistency or the global consistency is going to affect all your VPCs, all your VPC member ports, no matter how many VPC you do have on your secondary device. All the member ports of all your VPC portion are going to be down, but primary device is not going to be affected by this consistencies. Okay. So in our next section, we will discuss about spanning tree.